Welcome back to Who Has the Best Theorem. Today we will be interviewing 4 founders of calculus and seeing which one of them has the best theorem. Let us meet our contestants.
First up, we have the genius who initially published proof of the fundamental theorem of calculus, James Gregory. Next, the man who built the foundation of an important topic in calculus, the mean value theorem, Augustin Louis Cauchy. Next, we have the man who gave calculus its foundational spine with the intermediate value theorem, Bernard Bolzano. And finally, the man who put his name on his famous rule, Marquis de L'Hopital.
Alright everybody, the rules are simple. First, explain your theorem and then tell us why it's best. First up is Gregory.
Thank you. While Isaac Newton pretended he invented the universe with an apple, I published the first fundamental theorem of calculus in 1668. Before me, calculating the area under a curve and finding its steepness was treated like two completely different things, but the fundamental theorem of calculus proved they are inverse operations. If you want to integrate a continuous function, f of x, from a to b, you don't need to sum up all the infinite numbers. You just find its antiderivative and calculate. It connects the rate of change to total accumulation. Without it, you don't have modern engineering, physics, or technology. I basically built the engine of the modern world.
His proofs were just stating the obvious. He didn't even have a strict definition of a limit. Speaking of strict definitions, here we have Augustin Louis with MVT.
Thank you. While the others played with vague concepts like inverse functions, I gave the mean value theorem its definitive form. The theorem states that if the function is continuous on the closed interval a to b and differentiable on the open interval a to b, then there must be at least one point c where the instantaneous rate of change, f of c, equals the average rate of change, which is f of b minus f of a over b minus a. Think of it as if you're going on a road trip. If you drive 120 miles in 2 hours, your average speed is 60 miles per hour. My theorem proves mathematically that at least once during that trip, your speedometer will read exactly 60 miles per hour.
The students are so boring. What happens when he faces a problem like 0 divided by 0?
And now for the intermediate form, Marquis, tell us about L'Hopital's rule.
When students encounter a limit like the limit of g of x over f of x as x approaches c, and it yields infinity, or they panic. But my rule saves them. You simply take the derivative of the top, the derivative of the bottom, and try again. My rule gives an easy solution to many students' worries.
He didn't even discover that. He gave Joanne money to mail him his discoveries and promised not to take credit.
All of it was voluntary and legal. Heck, I published it in my first calculus textbook, which I funded. If you got money, talk to me about it.
They're all arguing about how fast the car is going and how to find the limits, but they don't know about the road that it actually takes to get there.
Alright Bernard, tell us about intermediate value theorem.
In 1817, I turned mathematics into conceptual thinking rather than visual thinking. The intermediate value theorem states that if a function is continuous on a closed interval a to b and c is any number between f of a and f of b, then there must be at least one value c in that interval. For example, if you grow from 4 feet tall to 5 feet tall, you must have exactly 4.5 feet tall at some point.
Wow, amazing. If I walk from one place to another, I must pass the halfway point. That's so original.
At least my theorem didn't get ignored because Isaac Newton had better relations.
I literally died at 36. He needs to give me a break.
The truth is, Bernard's IVT is just a minor property of calculus. My MVT is what actually links the derivative to the behavior of the function. When the derivative is positive, the function is increasing. I literally brought the logic into calculus.
His logic takes 3 whole pages of text. 3! With my rule, just differentiate until the problem goes away. 0 over 0, differentiate. 0 over 0 again, differentiate again. It is far more practical.
His rule is tricky. If the limit isn't actually an intermediate, then it gives completely wrong answers. It's literally just for students who don't want to learn about real limits.
And none of the derivatives mean anything if the function isn't continuous, which is what my theorem protects. If there's a break in the graph, Cauchy and Georgi's theorems are not feasible, and L hospital divides by 0 or some reason. I am the one who shaped calculus to be what it is today.
I did it first though, so I win.
You didn't win anything. Your theorem was literally common sense.
I can buy you a theorem. I'll call it L'Hopital mean rule.
You guys are so irrational.
Thank you so much for tuning in to Who Has the Best Theorem. Remember, stay continuous with IVT and MVT. Don't forget your limits with L'Hopital's rule, and continue to find the antiderivatives with the fundamental theorem of calculus. Thank you.